All right, so let's get our Splunk instance up and running for some of the various labs that we'll be looking at as we get into tracing attack chains and hunting for threats later on in the course. And fortunately, this has been packaged together pretty simply, with a minimal amount of moving parts for us to worry about. And so we're going to use a pre-built Docker image, which contains the exact Splunk configuration and data for the labs. And so this approach is meant to keep things as simple as possible, in theory, and ensure that everyone's working with the same environment. And also, it makes it really easy to update this package in the future as maybe the curriculum grows or updates. And so the first thing we'll need to do is get our hands on an ISO image to act as our Splunk server. And you have some freedom of choice here because we're doing a Docker-based deployment. And so you can install this on any OS or distribution that supports Docker. The important part here is just that the system you build can run Docker itself, which shouldn't really be an issue because Docker is just so well supported. And so for this case, I'm just going to keep things as basic as possible and stick to Ubuntu. And so I'll have some links referenced to the Ubuntu website where you can get your hands on the ISO image. Now I'm going to go ahead and download the latest long-term support or LTS version of Ubuntu Desktop, which in my case right now is 24.04.3. However, if you want, you can opt to use Ubuntu Server. But just know that you'll have to set up some additional components like enabling SSH on the VM so you can get into it. And also you'll need to have some way of transferring the container files over. And so for ease of use, I'd recommend just using SEP over SSH or maybe a shared folder in your hypervisor if you have that as an option. And you'll probably need to set up an additional network interface on the VM so it's essentially dual homed, basically letting it sit in your lab network while still allowing you to access it from your host using SSH or accessing the Splunk web interface from your host browser. Again, this all sort of depends on the configuration that you prefer. And so the server ISO is obviously more efficient and lightweight because it's headless, but it just takes a little bit more work to set everything up. I'm not going to be able to walk through and cover every scenario here, and so if you do go the server route, I expect you know at least what you're doing. And so I won't run through the whole installation process since it's pretty redundant at this point, but basically I've acquired my ISO image, I've created my VM, in this case I'm running VirtualBox, and then I'm just walking through the guided installation process. The actual installation of the OS took quite a while, so I'm going to use the power of editing to skip over that and get to our desktop. Now, one of the first things I like to do when I set up a new desktop VM in VirtualBox is install guest editions. And so if you're using VirtualBox as your hypervisor, feel free to do the same here. Think of guest editions like these set of bonus drivers and utilities that can make our VM behave much more like a normal machine. Without them, things can feel a bit clunky. The screen might stay locked at a low resolution, our mouse might not move as smoothly, and we won't have the power of copy and pasting. So it's kind of this quality of life improvement that's, in my opinion, absolutely worth doing. Obviously, if you're building out your Splunk VM on a headless server version of the operating system, you can, of course, completely skip this as you're probably SSHing in. But before we can install it, the VM needs some preparation. And so I'll just open up the terminal for my desktop. And first, I'll refresh Ubuntu's list of available packages by running a sudo apt update. And then when I'm prompted, I'll just type in my password. And there we go. And so next, for guest editions to compile and install correctly, VirtualBox needs a handful of build tools and libraries. And so I'll go ahead and install them with a sudo apt install here. And the libraries we need are bzip2, tar, gcc, make, Perl, and then for good measure, I'll include Git as well. And so when we're prompted, we can just enter Y here if we didn't run apt install with the Y flag. And this is going to install, again, that set of packages to really give us everything we need to compile and build kernel modules. Because behind the scenes, guest editions is basically just a set of kernel modules that get added into Ubuntu. And so these tools are sort of required for us to continue here. Now, one more prerequisite are kernel headers. These are kind of like the blueprints for the kernel. And so without them, the build tools that we have won't know how to match the modules to our running kernel. And so let's grab them just by running a sudo apt install linux-headers-generic. Excellent. And so with that done, we're now ready to install guest editions. And so I'm just going to go up to the VirtualBox menu here at the top and click on Devices. And then I'm going to select Insert Guest Editions CD Image. And so what this is going to do is mount a virtual CD into the VM that contains all of the installer files that we need. Now back in the terminal, that CD is going to be mounted under the /media directory inside of our username folder. And so my account is called Splunk, and so I'll just move right into that folder there. And specifically, we want to head into this VBox or this VirtualBox Guest Editions folder. And so I'm just going to hit Tab there to autocomplete so I can jump into it. And if I run an ls here, I can see a bunch of files. Specifically, this script here called vbox linux editions.run. And so this is the installer file that we need. And so to kick it off, I'm just going to run a sudo here to run it with elevated permissions, and then just do a / here to source that file. Again, vbox linux editions.run. And so once we kick this off, it's going to go ahead and compile and install those drivers. And so while it does this, don't be too alarmed if the screen kind of flashes around or if you see the resolution change, a few times while it runs here. This is all completely normal. It just basically means the new video driver is kicking in. And so once the script finishes, as we can see here, we just need to reboot our system so all of those changes can take effect. And so I'm just going to run sudo reboot and then provide the now argument here to kick that off. And so when the VM comes back up, you'll hopefully notice that things feel a bit smoother. At this point, I like to switch VirtualBox into full screen mode, just like that. And then I'm just going to go ahead and log in here. And what I can do is enable the bidirectional clipboard, which makes it a ton easier for me to copy and paste commands directly between my host and the virtual machine itself. And so this way you won't have to manually type out every single long command that you want. All right, and so with the VM tuned up here, let's actually move into what we are intending to do here and install Splunk. And so you should have received the SOC 201-Splunk compressed tar archive file from the course. And this is a pre-built Docker image that already contains Splunk and all of its configurations and indexes and data that we'll be using. And so ultimately, the installation here from this point is fairly straightforward. So as we can see, I've just put it in my home directory here to make it easier to access. First, though, we need to have Docker installed. And so head back into the terminal here, and as before, make sure everything's up to date. And so this time I'm just going to run another sudo apt update and a sudo apt upgrade here. Excellent. And so now let's go ahead and install Docker. And so I'm going to run a sudo apt install docker.io. And this is going to start to pull in the Docker runtime directly from Ubuntu's repositories. Perfect. Now next, we probably want Docker to start automatically whenever the VM boots. And so to do that, we can enable it as a service to start automatically. And so we can do that just with a sudo systemctl and then run enable -- now Docker. And so enable is going to make sure that Docker's set to run at boot, and this now flag here tells it to start right at that second. One more thing, by default, only the root user can run Docker commands, and so this means you have to type in sudo every time, which can kind of get annoying. And so to fix this, let's add our user to the Docker group. And so I'm going to run sudo usermod, and then the G argument here for the Docker group, and then provide the environment variable for our user. And so AG here just means append to group, so this adds our account based on the user environment variable, which resolves to our username, and adding that to the Docker group. Excellent. And so for this change to take effect, we actually need to log out and then back in. The lazy way to do that is to just reboot the system again. And so that's what I'll do here with a sudo reboot now, and just wait for that to start back up. And so after the reboot, we can test out our Docker installation with a simple command here. So back in the terminal, I'm going to run a docker run and then provide the image hello-world. And so when we run this, Docker is going to check for a very lightweight image called hello world. If it's not already downloaded, which it probably won't be, it's going to grab it from Docker Hub, which we can see it's done here. And then it's going to run a container from that image, which as we can see here, prints out the message hello from Docker. And so if we see that, well, congratulations, Docker's installed. And so it looks like we are good to go here. Now let's load up our Splunk lab image. And so assuming you place that compressed archive file in your home directory, what we can do is run docker load to import an image from a tar archive. And then using the less than operator here, I'm going to point it over to that compressed archive. Now, this isn't a small file, and so it can take a little bit of time. And we should start to see, there we go, some activity kick off after a few moments. Excellent. And so once it's loaded, we can confirm this by running Docker images. And so this is going to list out all of the available images that we have. And so at the bottom here, we can see the test hello world image that we pulled down, but we should now also see the SOC 201-Splunk image in the list. Great. And so if we're here, we're now ready to launch it. And we can do that by running the docker run command with a few important flags. And so I'm going to call docker run with the D argument, and then provide the name here of SOC 201-Splunk. And then we have a couple of P arguments here for ports. I'm going to map 8000 over to 8000. And then for the second one here, 8089 over to 8089. And then just call it SOC 201-Splunk. And so again, the D argument here is going to run it in detached mode, so it's in the background. Obviously, the name here is pretty self-explanatory. We're just giving our container a name so we can reference it more easily. And then we have some port mappings, right? So we're mapping port 8000 on the VM to port 8000 inside the container, which actually refers to Splunk's web UI, which we'll be accessing in a moment. And then we're doing the same thing for Splunk's management port, which is 8089. And so this should just take a second to start up. And once we get our prompt back, we're going to see this long hash value. Now, this is our container ID. It's basically a unique identifier for this running instance. Now, we don't need to memorize it or reference it because we've named our container something easier to remember, but it's good to know what it is when you see it. Now, to check and verify that it's running, we can just type in docker ps. And this is going to show us all of our running containers. And so, like we can see here, if you see SOC 201-Splunk in the list, well, that's a good sign. Specifically under status here, I'm zoomed in right now, so some of the columns get kind of messed up. But we can see that it's listed as up as of 8 seconds ago, and its health status is currently set to starting up. If something went wrong, you might see that the container immediately exited, and so you should be able to hunt down the logs in that case to see what happened. And so I'm just going to give it a few minutes here so it can start up and build everything. Splunk usually takes a bit of time to start up anyways, and so it's always a good idea to be patient. But after some time, I'm just going to run another docker ps command to make sure that, it hasn't exited or anything. And as we can see, it's been up for 2 minutes and is set to healthy. That's what we like to see. And so at this point, we're done pretty much. Splunk should be up and running. And so to verify, I'm just going to run Firefox here to open up my web browser. And specifically, I'm going to navigate over to http://localhost on port 8000, which again is the port where Splunk's web interface can be found. Right, because of the port flags that we passed in when we started up the container, requests to port 8000 on our VM are going to be forwarded into the container itself. And so by going to localhost port 8000 inside the VM, we're going to be hitting that Splunk service directly. Now, there's also an optional step here if you'd rather not use the browser inside the VM. By default, everything we've done here is local to the VM, but if you wanted to, you can configure the networking so that Splunk's web portal is reachable from the outside too. Right? So whether that's from your host operating system to really make things easy, or even from other VMs in your lab. And so again, this is hypervisor dependent, and so feel free to look up the documentation for how you might want to do that. But the simplest way is to just add in another network adapter and attach it to your lab network, for example, as a bridged adapter or a host-only adapter. That way, your Ubuntu VM gets an IP address on the same network as your host and other machines. And once that's in place, instead of browsing to localhost inside the VM, you can just hit your VM's IP address in a browser from your host or from any other system on that network. And so that's entirely optional and sort of gets into the networking side of things within your home lab. And so if you're comfortable just running a web browser inside the VM, everything works out of the box here with no extra setup. All right, and so after navigating to the web portal, if we're seeing this Splunk interface here, then we're good to go. You may see this message or notification here in the list. You can just delete that. It's just kind of a default warning message about allowed domains that doesn't really apply to us in a lab environment. And so aside from that, that's pretty much it here. Thankfully, Docker makes this entire process just so much easier. Now, when you're finished with your session, or if you just want to stop the container for any reason, you can just call a docker stop command here and just provide the name of that container. And so again, remember we called it SOC 201-Splunk. So we can just provide that there. And once it's been stopped, if I run a docker ps again, we can see that we no longer have any containers listed. And so if we wanted to start it back up, we can run the aptly named docker start command and again, provide the name of that container. And so just a note on that, when you reboot the VM, Remember, Docker itself will start automatically, but your Splunk container won't unless you set it to. And so to bring it back up, again, we can just run docker start and then provide the name of that container. Or if you prefer to launch it on its own every time, you can include the -- restart unless -stopped flag when you run the container. And so I'll have a command referenced on how you can update your container with that option enabled if you want to. And finally, for whatever reason, if you ever want to actually remove the container completely, well, you can just run a docker rm here for remove and then provide, again, the name of that container. And so this is going to delete that container, but it's still going to keep the image. And so if I run docker images again, we'll notice that the SOC 201 Splunk image still exists. And so if you wanted to spin up a fresh container later, well, you can do that no problem, right? We don't need to reload the image unless you've removed that too. In which case, if you did want to remove the entire image for any reason, you can just run a docker rmi for remove image, and then once again, provide the name, in this case, of the image SOC 201-Splunk. And as we can see, it's been fully deleted and no longer exists in our image list. And so we'd have to, again, load it in from scratch. And that's pretty much it. We're now up and running with our Splunk server, and maybe, along with that, a little bit more knowledge on how Docker and containerization works, and how useful it can be when setting up these environments.